Hello and welcome to this video about building web APIs with Rust. I am just coming out of giving this very presentation at the Eurorust conference, and at the Eurorust conference I only had 30 minutes to present the content. That's absolutely okay and exactly the right amount of time because there are so many awesome speakers and so many great content to cover. However, I thought that I'd take a few more minutes now to show you a little bit more about what I created and the samples, and to give you a little bit more detail for those of you who would like to dive in a little bit deeper than just taking a look at this topic for 30 minutes. Let me quickly introduce myself. My name is Rainer Stropik. I'm a passionate coder here from Austria. I have been doing coding for over 25 years now. I work a lot with Microsoft. I'm a Microsoft MVP and regional director. That does not mean that I am on the payroll of Microsoft. On the contrary, I have my own consulting business. We are a, let's say, boutique consulting company doing work with small, medium and large customers in the area of cloud computing. Besides my professional work as a software architect and software developer, I'm also a trainer, teacher and mentor. I teach at the local high school for computer science. I'm a mentor in the community, and there especially in the Coding Club Linz, where we run Austria's largest and most active coder dojo. The Coding Club Linz also runs the Rust Linz meetup where I have the honor to be one of the co-founders. And with that, you know all that is to say about me. If you want to get in touch using any social media platform, like for instance, I don't know, maybe LinkedIn or Twitter or something like this, feel free to look me up and send me a connection request. Let's go into the topic. Why did I create this presentation and how did I go about it? Let's talk about that a little bit before we dive right into the topic. First, let's cover the why. Why do I think that this session, that this topic needs a presentation or a video or some additional content? You see, Rust is a great language. I love Rust. I'm passionate about Rust, and Rust is becoming more and more popular. That means that more people are attracted to this language and to this platform, and those people come from other languages and other platforms. They might not have a huge background in C or embedded programming, so Rust might feel a little bit intimidating at the first glance. Because the home ground of Rust, where it was originally used most, is exactly in that area. Systems programming and embedded programming and things like that. But when more and more people come onto the platform and learn to value the unique properties of the Rust programming language, those people are also going beyond systems programming and embedded programming. They want to do regular software development, like for instance, implementing web APIs. When you come to the Rust ecosystem and you would like to implement web APIs with Rust, you might feel a little bit overwhelmed. For instance, I do a lot of work also in the C# and .NET world, and when you want to implement an a web API, you typically always use ASP.NET Core. That's the go-to framework that you use there. There is no big question about that. Want to use .NET? Want to build a web API? Use ASP.NET Core. But in Rust, it's more like in the JavaScript world or in the Go world, where you have a lot of web API related frameworks. So if you approach this topic, you might ask, where should I start? What should I use? What are the correct frameworks? Where are the advantages? What are the different approaches? And these are exactly the kinds of questions where I would like to give you a little bit of a starting point. So the goal of this session is to be a guide through Rust's rich and diverse web API ecosystem. Don't expect a deep dive into all the different platforms. Don't expect an exhaustive market analysis. It is an overview. I would like to share my personal experiences, opinions and preferences, and provide kind of starting point for a deeper project-specific research. This is exactly what this session is all about. Now, how did I go about it? First, I've done a personal selection of 4 Web API frameworks. These are Web API frameworks that I am particularly interested in. If you don't find your favorite platform on my list, or if you want to know more frameworks, there are definitely more than just these 4 frameworks, you can use my slides and use the links here and here to find websites where you have a more exhaustive list of possible frameworks, components for web development, web server development, things like that. My personal selection criteria for my 4 frameworks here was first, the frameworks have to be widely used. So they have to have a huge number of downloads according to crates.io. These frameworks have to be feature-rich. So I'm not covering very niche frameworks. They are really feature-rich and cover essentially everything you need to build a successful RESTful web API. Another criteria was that all frameworks should be based on Tokio. Tokio is the async runtime and the whole technology stack built around it. I really like Tokio. I think it has a great future. So I have chosen frameworks which are based on the Tokio stack, with one tiny exception, and we will talk about that at the very end. It has to build on the stable Rust, so no need for nightly Rust. And last but not least, one important selection criteria was also personal interest. So this is, again, as I said before, not an objective market study or something like this. This is really a lot about my personal interests and sharing my opinion and experiences. If your framework is missing, your favorite framework, I am very sorry. I apologize. We only have limited time. I have limited time for presenting and preparing. So don't worry, and please don't misunderstand my choosing these 4 frameworks that you will see in a second. If your framework is not in there, that does by no means say anything about the quality of the framework, okay? So please don't be angry with me if I haven't, or if I will not talk about a framework that you are very passionate about. All those community developers, all those open source developers, they do a great job independent of how many people use it. We value the ecosystem that is available in the Rust Web APIs area very much. So what is the agenda of today's talk? We will dive into the frameworks Actix Web, Rocket, Warp, and Axum, and at the end I have an additional treat for you. Quick glance, but I don't want to spoil anything. We will start with a quick intro, then we will take a look at some code, and finally I will give a personal statement about each of these frameworks. And if I go back here, I can also tell you that I have created a simple API for a to-do list, which I implemented equally on all these platforms, for all these platforms. And please use the link here if you would like to dive deeper into the different code bases. At the end, we will do a quick closing, and that's it. Okay, that's it. That is the agenda for today. So let's dive into the for loop and start with the first framework, Actix. On the right-hand side here, you always have for each framework some links if you would like to do further research, personal research. So please feel free to use my slides as a starting point for your personal research. Let me tell you a little bit about Actix Web. It is well established. It has been there for quite a while. It is well maintained. You get new releases every few months. Currently, the latest version as of today is 4.2.1. And yeah, Actix is pretty feature-rich. If you take a look at the features that it covers, it's pretty amazing what this framework is capable of doing. It also supports support for WebSocket, if that is something that you need for your projects. It is important for some of my projects. Actix is known to be fast. To make one thing very clear, I don't do benchmarks because I know that benchmarks depend on many factors. Some people need the best runtime performance. Some people need the best memory efficiency. Some people value developer productivity much more than runtime efficiency. Benchmarks are a little bit tricky. However, the Actix Web framework is covered by the Tech Empower benchmarks, and their results are pretty amazing. So big hand of applause for the creators and maintainers of Actix. They do a great job in terms of performance when it comes to official benchmarks. And with that, let's take a look at code. This is how we are going to go about it. I will show you some examples, the same web API in all the frameworks that we will cover. So you get an impression how the API feels, how the code is structured, and then you can decide based on these informations what you like best, and then you research more and play a little bit with the framework. So let me go into Visual Studio Code here and show you the structure of my solution. If I zoom in a little bit, you will see it quite nicely. I will mark it here. We will start with Actix, and after Actix you see the other frameworks that we are going to cover. We will continue with Rocket. After Rocket we will take a look at Warp. After Warp we will take a look at Axum, and I have implemented the underlying business logic for my to-do list here in this to-do logic project. So this is not a web framework. This is just the underlying web logic project. And at the end, I told you already, and now you see the spoiler, we will have a look out into the world of WebAssembly by taking a look at the Spin framework. But this is, yeah, a little bit different, and you will see why I say that in a second. So let's take a look at this web API. But before we take a look here, we'll run it. Just run Actix Web. I have a just file here. If you don't know just, take a look at it. It's awesome. I really like it. I say just run Actix Web. It's compiling everything, and then the web server comes hopefully up in a second. In the meanwhile, I can open up my REST client here. You see, this API should be capable of delivering a list of to-dos. It's currently empty, as you see. I can post something like this here that will add something to the list of to-dos, you see. Let's post another few things. Now I added, I think, 7 elements, so I see a list of to-do items. I can add query parameters to my GET request in order to filter and do offsetting and paging and things like that, just to have something in the query string that I can tell you. If I scroll, you already saw the post request where I post in some JSON request. Then we can get a single to-do item by adding the item's ID. I can patch an item, so I can, for instance, set it to completed equals true, that is that one. I can delete an item, obviously, see it here, works nicely. And last but not least, I can store the current state of my to-do list into a file. You see it here, it's a to-do store.json. You will understand why in a second, why I did that. So this is what my REST API is capable of doing. And with that knowledge, we will dive into Actix Web first. Let me walk you through the code. Let's get rid of that one so we have enough space on the screen. Everything starts with a main function, and as I told you, all the frameworks are based on Tokyo, so essentially that's a Tokyo main. Here we use an Actix Web framework that will generate the Tokyo main function for us. The Actix framework uses the log crate behind the scenes, so you can simply create a logger that is compatible with the log crate. Here we have some shared state. I don't store my items, my database items in the database or in Redis or something like this. I really store it just in memory, and this is essentially the shared state. I will not talk in details about how I implemented that. Very, very simple operations like getting all items, getting paged items, and things like that. It's using a hash map behind the scenes. This is not our topic today. If you want to take a look at the code, it's available on GitHub. We focus on the web part, okay? Now let's take a look at setting up the web server. And here I'm going to zoom in a little bit, something like that. I like that one. And let me walk you through the things that are going on here. First, here we set up our HTTP server, as you can see it here, and this HTTP server is serving up a certain app. And this app consists of, first, let's take a different color here, middlewares. What you see here, I'm using the logger middleware in order to print all incoming requests on the screen. Of course, you can write your own middleware. Follow the link in my code if you want to learn more. Middlewares are kind of wrapping around all the different requests, and they can do logging, they can inspect the requests, very similar to what you might already know from other frameworks. The next thing that you see here is registering shared state. So this is a kind of dependency injection. What you can do is you can create state handling. For instance, in my case, it's the in-memory repository of our to-do items. And here I'm just adding exactly that one. Of course, you have to make sure that everything is thread safe. So you have to use arcs and some kind of mutexes, or in my case, reader-writer locks, whatever suits your needs. Then we come to the routes themselves, and here you have essentially two different options. Let's use a different color again. You have two different options. First, you can use services here. These services, they don't have a route, as you can see. No, the route is stored at the service, at the handler point, with a macro. So the service variant uses a macro to define the route. And the route capability here does essentially the same, but you do not use a macro here. You specify the route directly here. So you can work with or without a macro, just as you like, just as what you prefer. And finally, we bind everything on a socket, and we run the web server in an asynchronous way. This is how you set everything up. Of course, in real life, you will probably structure your handlers a little bit deeper. If you have hundreds of endpoints, the app becomes more elaborate. If you have lots of middlewares, if you would like graceful shutdown and things like that, please take a look at the examples that the Actix people provide here. We want to keep it simple, so you see the basic building blocks of the API. So this is setting up the server. Now let's scroll down and take a look at some of the handler functions. Let's take a look at the first one, the GET request first. What you see here is a method which delivers all our to-do items. This is the get to-dos, and here you see what you need if you use a service in Actix. You have a macro here, get to-dos, and that will deliver, that will respond to any get request on the /to-do route. I would like to draw your attention next onto the parameters of our handler function, and those parameters are so-called extractors. It's their job to extract data from the request. You can write your own extractors. I have added the link to the documentation here, so you can use custom data types if you want. So if you are using some domain-specific data types that have to get the data in a very unique way out of the HTTP request, you can definitely implement that. However, Actix comes with a large variety of existing extractors. For instance, extracting something from the query string, as you can see it here, extracting something from the path, extracting something from the body, things like that. You don't have to develop it, it's just there. Also, an extractor that gets data from the shared state, as you can see it here with this data thingy here, is also available. On the response side, there is a very central trait, which is the responder trait, which you see here. You can implement the responder trait for custom types. If you'd like to simply return a custom type and you have a specific business logic how to turn this custom type into HTTP responses, then feel free to do that. But again, Actix comes with batteries included if you want, so they have a lot of existing types, like for instance here, the JSON type, which implement the responder trait out of the box. So for the obvious things like returning JSON, you do not need to write anything. It's really, really simple. In my case, it's just three things that I do here. I get the reader lock from the reader-writer lock, then I extract some data, as you see it here, from the query string, and then I call the core business logic, which is separated in a separate crate here. So take a look at that one. That has nothing to do with web. It's just business logic for storing and getting the to-do items. That's it. The result is turned into JSON and we are good. So you see, this is pretty easy stuff. It's very easy to understand, and if you know other frameworks, like for instance from Node.js Express or ASP.NET Core or Go, Gin or something like this, you will probably feel immediately at home. Let's scroll down a little bit and let's take a look at more handler functions. The next handler function is a little bit interesting from a very specific point of view. In this case, this is a get to do, single to do item. First, we extract something from the path, but I think that is pretty obvious. But in this case, we need to return to different return types depending on the flow through the handler function. If we find the to-do item, we would like to respond with the JSON respond and HTTP status code 200 OK. But if we don't find the item, we would like to respond with not found, with HTTP status code not found. And the Actix framework offers a data type which is called either, as you can see it here, where you have to define what is the return type in one case and in the other case. One case returns the JSON, as you can see it here, and the other case, either right and either left, you see it here, the other case returns just a response code not found with a text body. Please use your imagination. Of course, you could add more complicated return stuff here. You could return standardized problem-detailed JSON if in case of the error and things like that. But I wanted to keep it simple to really focus on the very basic APIs of these frameworks. So, different response codes here. Let's go down and let's take a look at the next two handler functions. They are adding new to-do items and deleting a to-do item. Adding the to-do item needs to extract data from the HTTP body. And this is how you do it. You again use the JSON type, and this now acts as an extractor. So it extracts the JSON body from the HTTP request. And then again, we just call the internal business logic after acquiring a write lock, as you can see it here, to be thread safe. And at the end, we return a created response with a JSON body. The created response immediately implements the responder trait, so we are good. Now the next method here, the delete method, again has a parameter, as we saw before. I didn't mention that in the get single to do item, but I think you recognized it. And I don't think that we have to talk a lot about this function. There is nothing specific on it. Let's scroll down. There are more interesting things to come. Updating a to-do item is also pretty straightforward. We don't have to talk a lot about that. The last one here is a more interesting one. Let me scroll down first so you see why I am doing it like that. In this case, I would like to write something to the disk. And of course, something can go wrong when writing something to the disk. So I need to somehow signal that something went wrong to the Actix framework. And I would like the Actix framework then to turn that into a response, into an HTTP response message. And for that, I am using a custom error type. Here you see the custom error type, which I return in the case of an error. How is that technically done? You can see it here. I'm just using the question mark operator to exit the function if the persist method, which is part of my backend logic, has any kind of problems. So if the persist method does something goes wrong, this statement will exit and return an app error. How is that done? It's done using this combination of data type and implementation of from. This here is the error which comes back from the business logic. So my business logic crate returns a to-do store error. And by implementing the from trait, I can easily turn this to-do store error into an application error. So this is my application level error object. And of course, in practice, we would have more enum variants here. This is just one because it is a very simple demo exercise. Once you have this application error, and once you can turn all your internal error states into the application level error, what we can do is we can implement here the response error trait. The response error trait is then responsible for turning the specific app error into a status code, you see it here, and into a real HTTP response. So this thing has to render your error information into a suitable response, HTTP response. So you see, it's a very nice programming model. You can centralize your error handling and your handlers will just return your application errors, and turning these application errors into proper error messages is really straightforward. So a very nice API. I already ran this sample, so you already have seen it. So I think we can close that one and say Actix. Check. Let's go back to the slides and I will give you my thoughts about this Actix Web framework. I think it's pretty easy to learn. If you are an experienced web developer and you know other frameworks, you will probably feel at home pretty quickly. If you just want to implement a web API using Rust, you don't need very deep Rust knowledge. It's not crazy complex with types and generics and so on. It's straightforward, so it's even suitable for beginners or Rust coders with intermediate knowledge. It's perfectly fine. I personally like the API, the programming model, very much. Everything is typed, everything is pretty straightforward. You can use macros, you don't need to use macros. It depends on your personal preferences. The documentation is okay. Documentation is available, conceptual documentation, API documentation. You have a large large selection of examples, so from that point of view, nothing to complain. Actix is not my personal favorite. I will tell you what my personal favorite is, but if I would have to implement the project with Actix because a customer would like to do so, I would be happy. I would enjoy doing that, and I would probably be very glad with what Actix Web offers me. So these are my personal thoughts about the Actix framework. And with that, breathe in, breathe out, next framework, Rocket. Rocket is, I have a personal deep relationship with this framework because it was the first framework that I took a look at when starting with Rust some years ago. So I do a lot of distributed systems development, so building web APIs is something that I very regularly do. And therefore, when I have tried Rust for the first time, I immediately wanted to know how can I build a web API. And Rocket was the first framework that I took a look at, and I really loved it from the very first moment on. Let me tell you a little bit about Rocket. Rocket is, again, well established. It exists for many years. It's well maintained. It unfortunately has been quite a while since the last non-release candidate or non-preview version. The current version is 0.4, but I would not recommend to use it anymore because when it comes to 0.5, we are already at release candidate 2. But unfortunately 0.5, it has taken quite a while to work on this 0.5, but I fully understand that this is a huge project for the community that is building and maintaining Rocket. So please don't misunderstand my saying that as a kind of complaint. Absolutely not. I highly appreciate the work that the maintainers of this framework do, but it simply takes a while. It takes how long it takes, and it is like it is. Rocket is a pretty feature-rich framework. For instance, it includes support for the Diesel object relation mapper, but unfortunately it doesn't include WebSockets, which is a bummer a little bit for some of my projects, but hey, it is like it is. Maybe it will come in the future. The Rocket claims to be simple. Rocket claims to be complete. Let's say it's battery included, which it is, in my opinion. It also claims to be fast. Benchmarks, or at least some, let's say, official benchmarks, say that it's a little bit slower than the other frameworks that I am going to talk about or already did talk about, like Actix. But hey, for my projects, that's really not a thing here. The web API framework, at least in my project space, was never an issue in the past. I do a lot of work with databases and things like that, and they are magnitude slower than anything that a web framework could add. So other things like good async support and developer productivity, I value them more than the last tiny bit of performance in terms of web, but I fully understand that this is different from project to project. Are you interested in the code? I will show you the code. Do I need to run the app again? You have already seen the requests, and as I said, in preparation for this talk, I implemented exactly the same web API on all these frameworks. So I hope you can remember what we did, and yeah, I will dive right into the code, right? Okay, let's scroll up and go through it. Rocket. Setting up Rocket is kind of similar to setting up Actix, but still there are differences. We see that logging is again done using the log crate. There are additions planned in terms of logging, so logging is not the strongest thing here in Rocket, but it's okay. It's okay, at least in my projects. I can live with what is there. Setting up the server works like this. First, you might recognize, oh, I have to zoom in a little bit different, something like this. You maybe recognize that I didn't show you the main method because there is none. You use the launch macro here, which comes from Rocket. Rocket is heavily based on macros, so if you don't like macros, this might be not your framework. If you don't like macros, sorry. So the launch macro generates our Tokyo main, essentially. Here we have our shared state, as you can see it here. And down here, we set up our rocket, if you want to put it like that. First, we have to mount the different routes. This is the base route, as you can see it here. And then we add all the different handler functions. And the handler functions, they have a macro on top of them. And the macro contains the necessary data for routing, so the route selector and things like that. You will see that in a second. But again, you see here we are using a macro again. That down here is sharing our state. We had that with the Actix framework too. In this case, we just say manage and put in our case, the database, which is just exactly the same as before, an in-memory hash map of all the to-do items with a reader writer lock around it, with an arc around it, because we need multi-threading capabilities. So this is how you set up everything. So let's scroll down a little bit and let's take a look at some handler functions. Let's take a look at the get list of to-do items first. Similarly to what you've seen with Actix, Rocket supports extracting data out of request. It works a little bit differently. While in Actix we had a structure, and we use the structure to extract query information. Here we use information in the route, as you can see it here, and we use regular data types like option and the usual data types to get data out of the route. You can again implement these extractors or route guards, or how some of them are called, by implementing the from param trait. If you want to know more about that, and if you want to implement your own from param for custom data types that get a specific data type from the path and the query string, and it's also possible to write route guards which extract something from the headers, maybe some authentication stuff and so on. This is exactly how you use Rocket's traits behind the scenes, and the documentation is really good. It's really good. I will tell you about that a little bit later. Last but not least, we extract the shared state using the state struct here, and finally we return JSON. It's again similar to Actix. This JSON thing comes out of the box with Rocket, and it implements the responder trait. Whatever implements a responder trait can be returned from a handler. So what you typically need, so something like HTML or JSON or something like this, comes out of the box. But if you would like to return your custom data type, that's perfectly fine. Just implement the responder trait, which knows how to turn your custom object into an HTTP response, and you're good. So very extensible at that point. That was the first one. Let's take a look at the next one. Nothing special here with the get single to-do item and the add to-do items. Same extraction here. This is an extraction from the path. Take a look here, the path template, pretty obvious, right? Notable is that you can return an option here. Option already also implements the responder trait. So option is automatically turned into a not found status code 404 if it is none, and if it is some, it translates into a 200 OK response code, and the JSON that you provide here is rendered into the HTTP response body. So very nice way of saying didn't find something, or I found something and here it is. Easy to read, easy to write. I really like that one. If we take a look at the add function down here, we for the first time see how we can deal with the request body. Here you specify the format, in this case it's JSON, and you specify the name of the variable into which you would like to include or inject the content of the HTTP request body. And in this case we use the JSON data format again. Everything else is pretty straightforward, just as you have seen it before. We have a response like created here, HTTP created. It's it is maybe worth mentioning that you can even use macros inside of here. For instance, if you would like to build the location header of your post create request, you can do that with an existing macro. Very nice thing. So if you really want to build RESTful web APIs which return the URL of the edit item using the location header, that's made very easy here with the Rust Rocket framework. Let's scroll down a little bit. I don't think that we have to talk a lot about delete and update. It's pretty straightforward. I already told you a lot about this, so yeah, I think we can jump over that. Kind of unique is Rust's capability to define application level errors. You see here an enum app error, and again I'm using the macro that Rocket provides for turning these application level errors into responses. In this case, I kept it consciously simple. I defined an internal error, whatever that is. Of course, in real-life projects, you would add more enum variants here. And you can add another macro, as you can see it here, to turn the business-level errors into HTTP response codes. And then you can easily return here the application level error, and Rocket will make it very simple to turn this error into a proper response code. Of course, you can implement the responder trait manually, but you don't need to, and that is in this that again shows that Rocket is very beginner friendly. It's very easy to use. It's very easy to get started with. So you see here again we use the question mark operator as we are used to in Rust, and that works perfectly fine for our error handling here inside the handler function. So you have seen the code, and let's go back to the slides. Here I have my slides. Here we were. If I scroll down, some thoughts about Rocket. It's easy to learn, definitely. I personally find it even easier than Actix Web. If you are an experienced web developer, you will definitely not have a problem getting started. I like the API. I like the programming model. I don't have anything against macros. Macros are fine for me as long as they work, and they do here in Rocket. If you dislike macros for various reasons, maybe because the Rust analyzer doesn't perfectly handle it, or the error messages are sometimes a bit, then it's maybe not your framework. But it is heavily based on macros, no question about that. Documentation, a double thumbs up. Really great job of the people who maintain Rocket. Documentation is available, not just API documentation, also conceptual documentation. It's already including all the new things that come or will come with 0.5 release candidate. There is a large collection of examples where you can take a look at various use cases, so very easy to get started. So, what is my summary? I've used it, I love it, and I'm eagerly awaiting the final release 0.5 and the following versions of the Rocket framework. That was Rocket. So again, breathe in, breathe out. Next framework, Warp. Warp is a framework that I have no personal practical experience with, but I wanted to add it here to the list of frameworks because I just don't want to show you frameworks which look very much the same, because Warp is very different. Warp is a little bit less active in recent times. The current version is 0.3.3. There is not so much going on in the Warp area here, but yeah, still it is a framework that is heavily often used, no question about that. There are different benchmarks. In some benchmarks, Warp is very good. In some benchmarks, Warp is somewhere in the middle. It's definitely not slow. So check out your benchmarks. Here, I think this proves the point. Benchmarks are, I wouldn't say meaningless, but in many cases, benchmarks aren't super useful, I would say. Warp has a very different approach from what you've seen before. In Warp, everything is built around so-called filters, and this is exactly what I would like to show you here. Are you curious? Let's take a look at the code. I don't need to run the API again because it looks exactly as the same as before. We will just take a look at the code. Here is the code. Let's go up and let's take a look at setting up the whole framework. What you see is it's based on Tokyo, of course, so we have a Tokyo main async as we are used to it. We use the log crate here, and yeah, I think we are good here. So let's scroll down a little bit. And here you see how you set up the different routes. Very different from what you have seen before. Let me zoom in. What we do here is we start with a single small macro. This is a kind of domain-specific language for defining the route on which you would like to listen, but then this is called already a filter. But then you go on by extending this filter using and or operations. For instance, here we say if this is the path, so filter all requests where the path matches this one, and the response, another filter, is and the request is a GET request, then another filter, and you extract some data from the query string pagination. And in this case, the filter is really adding something to the subsequent call of the handler function. In this case, we add a reference to our in-memory state. So we are adding state here. And then finally, if you did all these filter things, then you call the handler. So the handler gets everything set up using these combined filters. And because these filters are essentially a kind of builder pattern, you end up, and this is, if you ask me, the greatest drawback of this framework, you end up with pretty complicated and nested types. So you have this and then, and. This, especially for Rust beginners, this is pretty hard because these types are really complex, and it is also quite complicated for me to deal with errors and things like that. But the beauty here is that it is really, once you wrap your head around it and once it works, it's really easy to read. And it makes sure that the methods work properly. For instance, here we say extract the pagination object, which is just a filter when doing some queries. Let me remind you of what we do. Let me show you the, where is it, requests file. We added these pagination information. Okay, so if I go back here, this is what is extracted here, and if I scroll down to the handler function, here it is, it receives the pagination object. We don't need any extractors here anymore, as we need it with Rocket and as we need it with Actix. We get the plain object from our business logic. We get the ready-made database, which is just an in-memory shared state. There is no arc around it anymore or something like this. Okay. Yeah, the arc around, it's still there. Sorry, the arc is still around, but we don't need anything here in that area. So let me show you what's going on. If I remove that one, for instance, then in this case it should fail. It should fail in a second. Why doesn't it fail? Oh, maybe because it's running. Let's cargo build this guy. Give me a, yeah, now it's here. It just took a while. My Visual Studio Code was a little bit, yeah, it took a while. And you see, by using these strongly typed combinations of filters, Warp can warn me and say, hey, the function is expected to take 2 arguments, but it takes 1 argument. Something must be wrong. And that's perfectly correct, because if I scroll down, I just deleted 1 parameter, and that doesn't fit to the specification of the filter that I created above. So this part of the error message is pretty clear, but if I scroll to the right, I think it is somewhere here, you see that we have pretty amazing error messages. You see that one? Try to read that one. So many complicated Rust features inside of this error message. You could now say, hey, focus on the error message that really shows your problem, but having such error messages as you've seen just now is a little bit of a drawback for beginners. So yes, it works great. Yes, it's type safe, but this is my biggest con when it comes to this framework. Let's take a look at the rest here. The handler functions are really not interesting. They are not interesting at all. The interesting are these features, these filters here that we set up. See, the next one says I would like to create the add filter, and this add filter starts with the to-dos path. Then we have a post filter. We only want to react on HTTP method post. In this case, we are extracting JSON from the body. We again inject the shared state of our in-memory to-do list, and at the end we link the handler function, and we do that for all the different HTTP handler functions. Of course, in a larger application, we would probably use separate functions. We would structure that again so that we don't have a long list of filters. And the examples on the web page and the GitHub repository of Warp, they do a great job in showing you how to structure this for more complicated and larger APIs. At the end, our final API is then combined by using the OR operator. So we can say either it's a GET request, the GET request is this one up here, get all the to-do items. Or it is the add request. The add request is this one, this filter chain here, that allows you to HTTP post something to our web API. And if I go down, we have another OR here, we have another OR here, we have another OR here. So this is essentially the filter chain that is wrapped around the separate filters per HTTP handler. We can also use so-called wrapping filters, this one. We can wrap a filter around other filters, and with that implement a kind of middleware concept. In this case, we are using the log wrapping filter in order to add logging to our API. And I think you can imagine that it would be more or less easy to add additional wrapping filters here. Then we spin up the server, and we are all good. The rest is not that interesting because it looks similar to what you have seen before. We have to build replies. The Warp framework comes with replies for all the usual things, like for instance replying with a JSON payload or replying a status code. You do not need, like in Actix for instance, you do not need to have this either left and right extra type, but you can really do JSON and status code and use this, I would call it magic function into response, and with that you can return different replies from different areas in your handler function. In this case, I reply with JSON here, and I reply with the status code here. Adding, pretty straightforward. Deleting, pretty straightforward. Let's talk a little bit about error handling if you want to do application level error objects. Let's take a look first at the implementation of this persist thing here. What it does is it's taking the to-do store error, which you see here, and turn it into a custom app error. The app error is again our application level error object that you see here. And what you then have to do is you have to mark it with the so-called reject trait. And once it has the reject trait, the Warp framework knows, I have to scroll up a little bit, where is the persist? Here is the persist. The Warp framework knows that if it gets this object instance as a return value from the handler function, that this is an error and it has to recover from this error. And then we can provide a recover filter. If I scroll down a little bit, here it is. This is the handle rejection function, which takes in the rejection. We can check whether the rejection was our own application error. We can inspect the details of the application error and turn all this thing into a regular HTTP into a reply, which will then be in turn be translated into an HTTP response by the Warp framework. So adding these rejections centrally is a pretty nice thing. It's a really pretty nice thing that you can do here in Warp. So you have seen the code. Let's go back to our slides and I will give you my 2 cents about Warp. It's interesting, definitely. It was interesting learning about it. It was interesting playing with it, and it was an intellectual challenge for me. It wasn't that easy. I've seen quite a few web frameworks in the JavaScript space, in the Go space, in .NET, but Warp's filter concept was new to me. Maybe it's not new to you if you come from a different background than I am, but for me, the concept was new and it was definitely interesting. Personally, I am hesitant about this programming model. It is clear once you have it, but I found it rather complicated when it comes to finding mistakes. The error messages are partly really difficult to read because the types are heavily nested, as you have seen before. So I think beginners, especially people who approach Rust and start with Rust in order to quickly build a small web API, they might be scared away because of these type systems. The documentation is available, but it could be enhanced, definitely. It is primarily API documentation, and for me, when learning Warp, it was very useful to take a lot of look at the examples. So they fill a little bit of the gaps that the docs leave. So I personally would not use it in a new project, but it's definitely interesting, and it broadened my view about what you can do and how you can build APIs in Rust. So definitely interesting to explore. Axum. Now we have reached my personal favorite, my current personal favorite. After having used Rocket for quite a while, if I will spoiler that, I will say that at the end again, I would probably use the Axum framework now when I start with a new project. When researching for this talk, I found out that Axum is also a place, a very famous ancient city. I think it is in Africa, and this is where this photo is from. It's a Wikipedia photo here. So what is this Axum thing? Axum is, compared to the other frameworks, rather new, but it's currently getting a lot of attention and traction. You get new versions pretty rapidly, so new versions every few months. We're currently at 0.5, but this presentation is based on the recent 0.6 release candidate 2 version. So this is not based on the 0.5 release. The unique property of Axum is that it is highly embedded in the Tokyo stack. So it's in the Tokyo GitHub repository. I think it's built from people either from the Tokyo team or at least very near to the Tokyo team. It does not come up with your own with its own custom middleware system, not at all. It relies heavily on other parts of the Tokyo system, especially Tower HTTP, and so on. So if you build services for Tower HTTP, you can also use them in Axum. So this is really the unique point of Axum, the tight integration into the Tokyo ecosystem. There are no macros. Oh my god, first time, no macros. Axum is, I think, completely macro-free, I think. But that wouldn't scare me away. I don't know what about you, but for me it would be perfectly fine to have a system with macros here, and it seems to be pretty fast. Again, I told you I don't do benchmarks. I don't really care about benchmarks, but still, Actix is in the official Tech Empower benchmarks, and it's pretty fast. So clap. A big hand of applause, a big round of applause for the community that is maintaining and extending Axum. Great job, really good job. Do you want to see the code? Absolutely. Now, I think we can make this one rather short because the code will look surprisingly simple to what you have seen before when we took a look at the Actix framework or the Rocket framework. So I will focus on pointing out the differences, the unique features. Okay. So first, it starts with logging and tracing. Logging and tracing is obviously important, and here we again see the tight integration with the Tokyo ecosystem. It's using the Axum framework uses Tokyo's tracing library that you can see here. I set it up here for demo purposes. So yeah, take a look at this library. It's important, but you see how tightly it is integrated with Tokyo. If we scroll down a little bit, you see the very clear and concise work that they did for setting up the different routes. I think I don't have to describe anything here because it's pretty clear. We add some shared state here with the with_state function, and then we specify the different routes completely without macros. We use the route templates here. We use some methods which represent the HTTP methods here, and we specify our handler functions. And at the end, you see here that we can add, and this is where Tower comes in, that we can add different layers and layers on top of each layers. In this case, I'm adding the trace layer, which is a service, a Tower service, and with that, all the different requests go through these layers, and they can do whatever they want. So this is the middleware system, and again, what I already told you, very tightly integrated with the rest of the Tokyo stack, and I personally really love that. Finally, we are setting everything up. If you want to have graceful shutdown and so on, please take a look at the example repository. Axum has great examples for all the different use cases. The the handler methods, they are very similar to what you have seen in Actix and what you have seen in Rocket. Here, these thingies are called extractors. So if you want something from the query string, you use the query extractor. If you would like to have access to the shared state, you use the state extractor. And on the response side, you have a trait which in Axum is called into-response. You get the most important structures supporting into response out of the box. So if you would like to return, for instance, JSON or an HTTP status code, you don't need to implement anything. It's just there. If you want to return your own types, you have to implement your own version of into response. I think we covered that already. The same is true for the other extractors. This is a path extractor. If you want to get something out of the path, which you see here, parameter, then just use the path extractor. If you want to get something from the query string, from the HTTP request body, then use a JSON extractor. JSON is in fact an extractor and also a responder. So you can use JSON here to get out something from the request or add something to the response. Also, returning different error types for different flows in your handler is very straightforward with Axum. Here I'm responding with JSON if I found the to-do item, and I'm responding with not found. Note that we are using a tuple here and just call into response on it, and that will do all the necessary magic to return the status code and the proper HTTP body. Of course, in practice, you will not just send back not found, but hey, excuse my being simple here because yeah, this is an overview presentation. I scroll down a little bit, delete. Pretty straightforward. I don't think that I have to go into very much details. I think by just taking a look at the simplicity of this handler function, you see how powerful this API is. It's really not a lot of boilerplate. It works very nice. The update method, again, a path extractor, a state extractor, a JSON extractor for the body, and the rest is just business logic. What about custom error handling? You can add your application level error objects, just as we did before. And I implemented again the from the domain specific error, which is in my data access layer, my simulated data access error, into the application level error. And then, if I have that, I can implement my handler and use the usual question mark operator to just return the app error. The question is, how is the app error then translated into a response? And the answer is the into response trait. As soon as I implement the into response trait for the app error, everything is fine, because then Axum knows how to turn my error into a proper error HTTP response. So again, pretty straightforward. You see how it works. Easy to get started and a very nice API. So you've seen the code. Let's go back to the slides. My thoughts about Axum. It's currently my favorite in terms of Rust Web API frameworks. I love the API. I love the tight integration with other Tokyo crates. So Axum is great. So this is really a very nice thing here. Documentation is available, but it could be enhanced. It is currently primarily API documentation, but the API documentation is really good. So I would not say that this is a big drawback because it's good enough. It isn't difficult to get in. If you are a professional web developer and you have seen other frameworks, you will probably, again, just like with Actix and Rocket, you will feel immediately at home. There is a large and super helpful selection of examples with lots of use cases. So whatever you want to do you want to add, I don't know, JOT authentication and things like that, they have examples for all of these things. So I am personally looking forward to do my first real-world project with it. And if I would have to implement a Rust Web API today for our own company and start a new project, I would probably go with Axum. But this is just my 2 cents, and I want to again emphasize that I'm fully aware that every project has unique requirements. So please do your own research and choose the framework that you like most and that fulfills most, that checks most of your boxes. We are getting closer to the end. What about the big elephant in the room that everybody talks about? WebAssembly. I'm super excited about WebAssembly. I think that WebAssembly has a huge future even outside of the browser. Inside of the browser, obviously, there are many frameworks which are already used heavily, especially in the enterprise space. If you think of Microsoft's Blazor framework, it does a great job of bringing C# with WebAssembly into the browser. But here I'm not talking about WebAssembly in the browser. I'm talking about building a web API as a WebAssembly module or WebAssembly component. Do we have a framework for that? The answer is yes. The company Fermyon has created a framework which is called Spin, and let's give it a spin. Okay, let's give it a spin. You have the links to the framework down here. It's different. It's different, and it's playing in a complete different. It's playing on a complete different level than the other frameworks. So do not expect a similar experience as with Axum or Rocket or something like this. This is very early. People at Fermyon and at the different communities working on this WebAssembly ecosystem, they are in a very early stage of development. A lot of new moving parts, and this is not mature. I am absolutely not saying that you should use this software for a business critical production app. This is something to experiment. This is something to get an early look at, to get an experience, to maybe make some first steps in the world of WebAssembly. This is not something that can compete or wants to compete with existing web frameworks already. So let's take a look at the Spin framework, and in this case I again would like to really start this application. So I say just how did I call it? I called it run spin. Just run spin. This is what I want to do. And I would like to point out that here I'm not compiling with cargo directly, but I call spin build. And this spin build here is at the end of the day calling cargo with the WebAssembly WASI target. So we are compiling the spin application in contrast to the other frameworks, not towards machine language, but we are compiling to a Wasm target. This will end up here in the Wasm32 WASI folder, and here you have the WebAssembly, which I reference here. So when I say spin up, it's spinning up exactly that, what a WebAssembly module. This is what's going on. And this config file here, this spin toml file, is also the entry point for our router. As you can see it here, we specify the router, but do you see what we do here? 3 dots. It just says everything that starts with to do. Do you think that you have a more elaborate router where you can do things like getting query parameters out of it, using parameters in the route and so on in the path? No, all of these things are not present at the moment. So you are on your own now. What Spin essentially does, and with that we take a look in the code. Oh, let me run it first so you see that it really works. If I get it first, I have an empty array here. If I add something and I get it again, you see I get a collection. If I patch it, I didn't implement patch. I think I implemented the delete one. See, I can delete something, and at the end it's empty again. Okay, keep that in mind. Keep especially in mind that we have a pretty large cookie here that I set. I will talk about that in a second. So now let's take a look in the code. As I said, you are pretty much alone. What Spin does at the end of the day is it gives you, as of today, a nice API where you have a type-safe access to the components of the web request. So you get the URI, you can get the path, you can extract things from the query string on your own. You have to even split it up. I can show you that. I have just for an example, for instance, here. How do we extract the pagination? By manually splitting up the query strings using the ampersand key here. By manually splitting up each parameter using the equals sign here. So you see, you have to do everything on your own. You're essentially on your own. You get the body of the request as an unsigned 8 slice, and you have to do the JSON serialization and deserialization on your own. All the goodness that you have seen in Actix, in Axum, in Rocket isn't there. Does that mean that this is not useful? Absolutely not. This is the future, if you ask me. In a midterm or long-term future, I think that we will see similar frameworks like the ones that I've shown you before, based on top of frameworks like Spin, in order to make our APIs run based on WebAssembly. I really believe in a glorious future of WebAssembly on the server too. In this very simple example, what I did is I implemented a manual router, if you want. So this is a little bit of routing. I have to manually match over the methods in order to call my business logic functions, as you can see it here. I've implemented my own poor man's helper function for responders. There isn't a ready-made responder trait with all the things that you have seen before. That's simply not there. You have to do all the work on your own. What you can't additionally do, I cannot store the data in memory because the state is lost from HTTP request to HTTP request. So having something shared state in memory doesn't work in this WebAssembly component space, at least not as it is implemented today. So we would have to store something in a persistence layer, like for instance a Redis cache or something like this. But I didn't want to do that in this simple sample. So what I did, I round trip the status of the database using a very bloated and heavyweight cookie to grant it. Yeah, that is not practically relevant. So if I post in some elements, you see the cookie is getting larger and larger, and once I delete something from it, the cookie is getting smaller again. That is not practically relevant, but for taking a look at how Spin works, it was kind of interesting, and I invite you to take a look and to play on your own, and maybe some of you even would like to build a rudimentary framework. I could imagine something like this. I would love to do it. It would be a great exercise, but unfortunately my time is very limited, and so is the time of many other people. So this is more or less a glimpse into the future, where how the world could look like in a few months or years. But generally, I think that this thing has a great future. So let me give you my 2 cents, my thoughts about Spin, and in general, my thoughts about WebAssembly-based web frameworks. What an awesome future. These are my 2 cents. I really believe in that. It's not just Rust working on this area. The language that I have most experience with, C# and .NET, also has a very strong investment into WebAssembly. And I also tried already to combine C# with Rust using projects like Wasm-time, where you already have C# NuGet packages and Rust crates, and you can take a Rust component and host it into a C# application. Everything is currently moving. If you think of projects like WAT, like WebAssembly Type System and WebAssembly Components, there is a lot going on. It's not ready. It's a little bit too early for production, so we have to be a little bit more patient. But I personally think this will be great in the future, and it's an awesome time to be a developer in the web API space. So what is the conclusion? What is the thing that I wanted to show you with this presentation? First, if you approach Rust with the goal to write web APIs, you have choices. So if you come from a rather opinionated, restricted world like .NET, you have to change your mind, because there isn't one framework here. You have a lot of choices and you must make a choice. Some people love that, some people don't love that. I hope that my presentation gave you a starting point for further research. Is Rust ready for web API development? Absolutely. It definitely works. You can solve your requirements, and you will end up probably with very performant and very good and very stable API implementations. Are we meaning Rust, are we at par with other platforms like ASP.NET Core? No, we are not. So if you expect a similar functionality as with ASP.NET Core, for instance, it's not there yet. If you think of the support of standards like, for instance, OpenAPI specification, also known as Swagger, or OpenID, OAuth, authentication protocols, and so on, logging frameworks, logging standards like OpenTelemetry, for instance, support for upcoming API protocols like gRPC, well, upcoming, they are already there, or GraphQL and so on. In large managed frameworks like ASP.NET Core, all these things are just built in, and all of these features are only a few lines of code away. It's very polished and a lot of people work on it. Don't expect this level of functionality. But if you come from a more JavaScript related background or Go related background, then you will immediately feel at home. The Rust frameworks work properly, very similar to what you are used to in JavaScript or Go. Now, to summarize it, is it fun? Is it enjoyable? Oh, it definitely is. So if you like Rust, and if you, like me, like building distributed systems and web APIs, give it a try. It's a lot of fun. You can benefit a lot from Rust's unique features, and I'm pretty sure that you will be successful and you will write awesome solutions based on some of the frameworks that I have shown you, or maybe some of the frameworks that you will discover if you take this presentation as a starting point for your research. And with that, I am through. I would like to thank you for spending an hour or so together with me, taking a look at the web API frameworks in Rust. Enjoy working with Rust, and I hope that many of you will immediately now, after watching this presentation, start to write their first web APIs with Rust. Enjoy it, have fun, see you next time. Bye.